Hey people, how are we going? Sorry I got a bit delayed today because bedtime reading got a bit delayed. But anyway, look, we're gonna get started today. I think today I was gonna look at what was I looking at? My washing machine is not making some terrible noises. Oh, hoping it's all right. So we're gonna be doing integration of rational functions. All right. So this is basically integration. Sorry, I'm just kind of like processing a couple of things. Integration of rational functions. Okay, so now look, the thing is, these are some, how do I call it? It's a bit weird, but hi Lauren, welcome. Hey boss, awesome. Daniel and Pebbles, nice. So the questions that we're going to be looking at today are going to look something like this. Now, I'm going to be honest with you, like I only know how to do this with long division, and I think like I saw this kid the other day, and he can actually kind of do these questions straight away without even just like doing long division. He can just look at them and just kind of does it, and I don't know how he kind of did that. I would love to have learned it, but unfortunately I didn't actually miss it. So I didn't listen when because he did it so quickly, and I needed some more time to actually do it. But anyway, look, we're gonna do this. Long story short, if you look at this, yesterday we did not yesterday, I think on Tuesday we did the integral, like we did this one, right? Like where if f dash of x is in the numerator, f of x is in the denominator, then we would write this as ln of f of x plus c. Now this is what we did on towards the end of Tuesday. But in this particular case, if you look at this question, what's happening is that we've actually got x here, and we've also got an x there. And so this is when things get a little bit dicey. And so what I've been kind of doing it the old-fashioned way is I've been actually doing it through long division. Now, if you are, and I know some teachers actually teach through synthetic division as well, but I've just kind of found, I've always enjoyed long division, so that's why I found it really easy. So today I'm just going to show you how to do that, and then we'll actually go from there. Hey Ishan, how you going, man? So what we're going to do is we're going to do long division. So we're going to put this as x minus 1, and we're going to put 3x plus 2 here. Now what I'm going to do is I'm going to do a little bit of recap of long division on the side here, which let's say something like 72 divided by 3. If you want to do 72 divided by 3, what you would do is you would actually go look at the first digit. That's a 7, so I'm going to go 2, which will be a 6, and then 7 minus 6 is 1. Bring down the 2, and I've got 12, so I would go 4 times 3 is 12, where this is equal to 0. So anyway, from there, with that kind of same idea, we are going to now figure out a way to get rid of this x here. So if we look at this, we've actually got x here, and we've got 3x there. So what we know going to do is we are going to actually chuck in 3. We're going to chuck in 3 here, and then we're going to do 3 times x, which is 3x, and then 3 times minus 1, which equals negative 3 actually. Oh wow, okay, negative 3. I just realized my streaming stuff is so slow today. Okay, so the next step is then I would go, what I've got to do is I've got to go 3x, take away 3x, and 2 minus negative 3. And when I do this, 3x minus 3x will become 0. 2 plus 3 will actually become 5. because remember that the two negatives end up being, what do you call it? Positive 5 there. So what we're really going to do is we've got this little kind of like long division thing that we've done right now. So then what we're going to do is the last bit. So we're going to rewrite 3x plus 2 x minus 1 dx. We're going to rewrite this as 3 plus 5, which is the remainder, over x minus 1 dx. So pretty much all we've done is, we've just rewritten that rational function to this, and then once we do this, we can just rewrite. Now we can integrate this. This is going to be 3x plus 5 ln of x minus 1 dx, and of course divided by the differentiation of x minus 1, which happens to be 1. That's pretty much it. I think the integration of rational functions, the hardest part or the most trickiest part is the long division part. Once you separate it out, then it's pretty kind of easy. Now I have a theory, and I could be completely wrong in doing this, and I'm just going to try it out to see if it actually works or not. And this might actually only work with these ones, but if I was to do I'm just going to go 3x minus 1. That's going to be 3x minus 3. So it's almost like, but if I want to get 3x plus 2, I would actually go 3x minus 3 plus 5. So yeah, I guess I'm kind of figuring out what I can do, whether I can directly replace that 3x plus 2 with, I think it would just work. Yeah, because then this will become plus 5 here, plus 5 here. So I could actually rewrite this as 3 times x minus 1 plus 5 over x minus 1 dx. Yeah, I guess, Lauren, I guess we could actually do that as well. Like, I think that's what I saw before. And I think that's what I've tried to do here. But it's almost like y is the same as, how do you know that it's equal to 3x minus 3 plus 5? Because all I did here was, like, I tried this. I just went 3. I put that 3 there. Then I took the x minus 1 and I expanded it. And somehow that needed to equal 3x plus 2. Lot delay, yeah. So what I might do is I might just give you a couple of questions, and I'm going to restart my the tablet here. So we will do actually no, we'll do a couple of easy ones to start off with first, and then hopefully we can then do a little bit more complex ones. So try this one here, 2x plus 3 over x plus 2 dx. Then try 5x minus 1 over x minus 3 dx. Massive. And then the last one we want to try is, and I'll give you a little simple one to do without long division. Oh, yeah. Lauren's got a great little idea to kind of work through, but how would that work, Lauren, with like x squareds? Does it work with x squared and x as well? All right, if you can screenshot this, folks, I'm just going to restart the tablet. It's laggy. Yeah, that's what I was kind of worried about, because I think when we did this with just linear equation over linear equation, that method works really well. But I'm almost like, how would you do that if it's like a quadratic, like a big quadratic at the top? Wow, it's still delayed. Oh, it's not too bad, it's catching up. After the finding the could you explain what you did after finding 5 in the example? I'm trying to think which line you're looking at, Sukhneet. So I'll put up a few line numbers. Or was it this one? Oh, line 3, from line 3 to line 4, all I did was I just integrated it, Sukhneet, because 3 will integrate to 3x. Ah, I forgot the biggest pain in the butt. Sorry, I forgot the plus c. I think I know where my mistake was. Did somebody even point out the plus c? Anybody point out plus c? You guys are terrible. I've been teaching you for 4 hours and we forgot the plus c. All right, so what I'm going to do is the first question I'm going to try and do this. What is it saying? Norman, did you write 5 as x plus 2 or did I miss something? No, Sukhneet, I basically did long division. And let me just point out what happened. This 3 here ended up there. The 5 ended up here. And the x minus 1 ended up there. So it's just rewriting that fraction with quotient, divisor I think it is called, and a remainder. So if we look at x plus 2 and 2x plus 3, it's kind of thinking about it like this, right? And I'm going to do Lawrence method here because it's like she suggested 2x plus 2 you would end up with 2x plus 4. But what you want is you actually want 3 there as the coefficient, so that's going to be minus 1. So then I could rewrite this as 2x plus 2 minus 1 divided by x plus 2 dx. Now when I do this, I can then separate it to 2x plus 2x plus 2 minus 1 over x plus 2 dx, and then my x plus 2's cancel out, and I've got 2 minus 1 x plus 2 dx. Ooh, the lag is terrible. Now when I integrate this, I am going to get 2x minus ln of x plus 2 plus c, and then divided by the differentiation of this, which happens to be 1. Yeah, I don't know why it's delayed. I have the only sole purpose of this tablet is to run. Let's get rid of that. Hang on. Just gonna get rid of a few things. This whole tablet, the only purpose it's for it is to run what do you call it? Everything is running. All right, let's try this again. Just restarted it again once more. The last Windows update just messed up a few things. Oh my god, I've never seen it this laggy. Is it because of the notebook? Let me just try another notebook. Give me a second, folks. No, this is laggy as well. No, I don't use OBS. I use something else, but I actually stream the tablet. But anyway, look, what I'll do is I'll do these two questions. I'll give you a couple of more, and then I'll try and restart the thing again, and hopefully it kind of works. All right, so with this one, what I'm going to do is I'm going to go 5x minus 3. If I do that, I'm going to get 5x minus 15. But what I really want is 5x minus 1. So that means I would need to add 16. And so when I do this, I am going to get 5x minus 3 plus 16 over x minus 3 dx, which means I'm going to get integral of 5 plus 16 over x minus 3 dx, which is then equal to 5x plus 16 ln of x minus 3 plus c. Did you guys get that? Why'd you guys get 14? Did I make a mistake? Ah, 14. Yes, you're right. You're right. That's got to be 14. Apologies. All right, so looking at number 3, we've got x plus 3 and x plus 6. Now this one is a nice and simple one because we can just rewrite this as x plus 3 over x plus 3 dx. So then we would get 1 plus 3 x plus 3 dx, which means we're going to get x plus 3 ln of x plus 3 plus c. What did you get, Daniel? 6 ln. Oh. Now look, what I'm going to do is I'm going to put up a question for you, and let's see if we try Lorentz method to see if it is going to work. And then in the meantime, I will try and restart this machine again, but this time I want to try the x squared one. So try this example out. Yeah, it's completely freaking hell, it's lagging so badly. So try this question, and then what I'll do is I'll restart the machine again and then we'll try it again. Sorry folks, it's just not fun today with this lag. What I can do is I will open up my notes so that you can still have part 4. Is it because it's not syncing? That's not it. I'll just add this as a source for now. Desktop capture, OneNote. Yeah, something's definitely wrong because it's never this laggy. So the question we were looking at was this one here. So try this one and see what happens, and then I will just figure out what the hell is happening here. Though mind you, this tablet is about 3 years old now, so it should be fine though, because the only thing I use it for is streaming. Daniel, did you try this example here? Lauren, did you try it your method and see what happens? Right, I think we might be back again. Let's try. It's looking promising. Nice. That looks much better. uh, 100 ping photo. I'm not sure yet. I really need to set aside some time, but I don't know when, but I'll have to figure it out. TJ knows about my time. Hey TJ. Yeah, that looks a lot better. Okay. So let's try this one. All right, now we're going to try long division first, and then we're going to try the other method. I don't even know what to call it. I think we're going to call it the Lauren Harris method at the moment, because I don't know what it's called. But let's see. We're going to look at the coefficients of x. X has got a 1. X squared has got a 1 as well. So all I'm going to do is I'm going to do x multiplied by x plus 1. Now if I do that, I end up with x squared plus x. Now this is kind of weird because it kind of just works out real nicely here. But yeah, that looks okay. So let's just see what happens. So that means I would now rewrite this as integral of x plus 1, because that's x squared plus 1x, minus 1, and that's over x plus 1, and this is over x plus 1 dx. Oh, I don't know what else to call it, Lauren, because it's like, I think it's going to work. In this case, it's going to work because we're going to get x minus 1 over x plus 1 dx. So when we integrate this, we're going to get x squared over 2 minus ln of x plus 1 plus c. Of course, don't forget to divide by 1, which is not necessary, but it's just good practice to actually do that. If I was to do this long division, I would go x plus 1, x squared plus x minus 1. So I'd multiply it by x, which means I'd get x squared plus x. And it kind of works out nicely in this, because that becomes 0. This just becomes minus 1. So we can rewrite this now as integral of x plus negative 1 over x plus 1 dx. All right. What did I forget? Did I forget x squared over 2? No, I didn't. X squared over 2 star. All right, that's yours, boss. Okay, let's try another question. Look, TJ, I'm going to be honest, like long division, if you do your long division correctly, you are bound to get the questions correct. So, I mean, like, let's try this, all right? I'm actually going to put up a couple of questions here. Let's try both of these questions. Now, you tried long division if you want to. So we're going to do x squared plus x minus 3 over x plus 2 dx. Or you could try the Loren-Harris method as well. So number 5 is going to be this one here. Let's try 2x squared, because I really want to know what happens when things get a little bit complicated. I have a feeling the Loren-Harris method will work only for linear. But let's try these two anyway. And I'll try and do the other one, different method in my head. I have a feeling you have to do long division for the harder questions. Sorry, Lauren. You get x squared plus 2x. Did you do long division, TJ, for this one? Just curious, that's all. Because I just get this feeling the other method is going to actually make it a bit more, it's like you almost have to do it twice, I get a feeling. Which is why I prefer long division. I don't think it's harder, Lauren. It's just you have to do it twice, that method. Essentially, you're actually just doing the 2 steps of long division. But look, I think the beauty of it is like in calculus or in maths, you can come up with your own methods and they seem to work up to a certain point. And then it kind of gets a bit more trickier. Because you think about it, I mean, like, who in the right mind would have actually come out with long division? Like, how did they even think about long division? You know, it's just an algorithm, right? It's someone trying to find a shortcut of doing things. We tried, Lauren. We tried to do something where we could actually have a method named after you, but alas, we did not. Yes, Sukneet. I think, when are we doing? I think next session on Sunday is my favorite because we're doing integration by substitution, and then after that we are doing more quotient stuff, and then finally we land into definite integrals, and then after definite integrals we go to area under the curve. So it's still a bit while away. Yeah, I think I'm sorry. I think long division is probably the way to go. I'm gonna do this long division, yeah. Oh, is Daniel gone? All right. So if we were to do this long division, definitely works, Lauren. Definitely works. That's like when somebody says to you, you know, what is it? Do 25 times 25. Do we really want to be sitting there adding 25? Like 25 times. No, all good, Daniel. I was just messing. Nah, as long as it works, yeah, it's fine, Lauren. You can have that method. All right, so we've got x plus 2 and x squared plus x minus 3. So in the first line, I'm going to multiply by x, which means I'm going to get x squared plus 2x. Next, I've got to subtract. X squared minus x is 0. X minus 2x will be negative x. Oh, I started to lag again. and then the minus 3 is going to come down, which means this it will become negative 3. So now I've got to multiply by negative 1. And if I multiply by negative 1, I'm going to get, not negative x, negative 1. So this will become negative x minus 2. And then once again, I've got to subtract both of them. So negative x minus negative x will become 0. Negative 3 minus minus 2 will become negative 1. So I should have rewritten this integral as x minus 1, number 4, minus 1 over x plus 2 dx. And if we do that, we're going to get x squared over 2 minus x minus ln of x plus 2 plus c. And of course, don't forget the integral of that, which equals to 1. Sorry, Lauren, I'm not going to try and do your method at the moment because I know it's just going to split it up into 2 ways. But try it out, Lauren. I mean, if it works, hey, look, if it works, it works. And if you become fast at it, then you can use that method, and you can even probably patent it. Number 4 looks right. Okay, let's try number 5 now. Yeah, that's what I realized as well. You got to do it twice, because if you look in the previous questions, long division was like kind of done in one line. But then if you look at the next lot of questions, long division takes like 2 lines, and because of that, you're working, Lauren, it'll also take like 2 lines. So if you have like x cubed and something like a few other terms, then I bet you it's going to take like 3 times for your method to actually make that work. But of course, that just means that things get complicated. But I believe that's pretty much how they do synthetic division, which I haven't done it in over 10 years, and I've completely forgot about it. But some of your teachers might use synthetic division as well. Oh, it's great for the linear because you can just do it straight away. All right, number 5. We've got x minus 5. And we've got 2x squared minus 4x plus 3. And then we're going to do x. So we're going to do 2x, which means we're going to get 2x squared minus 10x. We're going to minus and minus. So that becomes 0. This becomes 6x plus 3. Oh, I hate the lag. Then I'm going to do plus 6. And I'm going to get 6x minus 30. Oh my god, this is not looking promising. No, it does look promising. And then I've got to subtract both of them, which means I'm going to get 33 here. So then I'm going to get integral of 2x plus 6 plus 33 over x minus 5 dx. And that's all good. We'll just keep going. We'll find out what it is. So here we're going to get 2x squared over 2 plus 6x plus 33 ln of x minus 5 plus c. Now, of course, the 2 2's cancel out, which just leaves you with x squared. I think, TJ, you are on the right track for that. I'm all right, PSV. How are we doing? Yeah, that's my laundry done. Thank you. Thank you, washing machine. All right. Any questions with this so far? And if we're good with this, I just need to find a question for you that we can potentially do. If I can't find this question, we'll have to do it through, oh no, there's nothing there. Because this type of question generally comes under merit, but they try and put like definite integrals in it. So we might not be lucky. Because ultimately when we get to the exam questions, they tend to be like, you know, they combine questions. So that's why there's, you won't find this kind of questions as achieved. Majority of the time they tend to be like merit questions, but they'll have like an extra added bit to it. So I'm just trying to find a question that we can do. Yeah, see, like, oh, it's definite integrals, which we're not doing for another couple of sessions anyway. That was, you know, that's a merit. Sorry, one more question. No, that's Ellen. Yeah, folks, sorry. Unfortunately, all of these questions, like if you can do up to this part, they tend to be achieved. But then there's always a follow-up part to this question, which is going to be merit. And then, but we haven't done that definite integrals yet, which has like the little numbers on the integral sign. That's going to be done by like the end of next week. And then after that, we should be kind of like powering through it. Now, with this particular section, we're pretty much done. Because the next section that we're going to do, we do need a full hour for it, because the next one that we're going to do is integration by substitution. By the way, the other thing that's worth noting is, oh no, it wouldn't actually work. Yeah, it works for linear, but substitution also works really well for like any kind of ugly looking equations. So in saying that, we can, I mean, I'm happy to put up one more question. Should I put up one more question, or are we done for this and then we can call it? And I've got a little, yeah, I've got to do something at the end of this session. Let me know. Do you want to do another question, or are we happy with this and we're like, nah, we're good, we can move on kind of thing? One more question. Yeah, good. Okay, yeah, we'll do one more. One more, and I actually remembered that I haven't actually done my July t-shirt giveaway yet. So apart from awesome, I don't know if you've, like, I've got your jumper. Like, I know I was supposed to do it last week, but I got carried away with work, man. Like, it's all there in my bags. I just have to go drop it off at the post box. Not the post box, what is it? The post people. All right, try this one here. Should we do, oh, this is an interesting, no, this is not an interesting, actually no, this is an interesting one. Let me do this one. Let's just see how you go. We'll do it next, Sukhneet. I'll actually put all of your guys' names. We'll do like a quick one so that no one else knows. Where is that window? I'll start putting your people's names in. If you want to be in, just throw me your names. I know Sukhneet is in, and I know probably Daniel. Daniel's definitely in, right? Yeah, TJ's in. So let me put TJ first. Look at that, 100% of TJ winning. Yeah, Lauren. You know, if Lauren, what is it? If you win it, we've got to actually put something else on the t-shirt. Like, I invented the Lauren Harris method or something like that. Sukhneet, am I adding you in? I don't know. You guys tell me. At the moment, it's just between TJ and Lauren. Oh, I can do that, Lauren, if you do, because it's like Sukhneet. Yeah, awesome. You can go in. You can get your differentiation hoodie and as well as a t-shirt at the same time. At the moment, it's just the four of you. That's crazy. All right, let's finish this question and then I'll open it up for the rest. While I do that, I'll actually set up the next stream for that. Where is my... What is it? July giveaway. Yeah, July giveaway. May. Nah, I'm only doing 3 t-shirts today. Yeah, I got you, Pebbles. I've been told off by my management that I need to make sure that there's a little bit more views before I can start throwing things out. July 24. No, July 24. T-shirt giveaway. Yeah, nice. Got that. File, export. Now, I'm going to be brutally honest with you. This was a bit of a trick question because I knew that you might do something like this. But this question, you didn't actually need to do this rule at all. I kind of tricked you folks into it. Because what you could have done with this question is you could have just done it like this. You could have gone 2x squared over 2x squared minus x over 2x squared plus 1 over 2x squared dx. So we're going to get 1 minus 1 over 2x plus 1 over 2x squared dx. So that means we're going to get x minus ln of 2x divided by the differentiation of 2x, which is 2. And then here I would have had to write this in the numerator, which means I would have got x to the power of negative 2 over 2, which means I would have actually got x to the power of negative 1 over 2 times negative 1 plus c is what I should have got. So I should have ended up with x minus ln of 2x over 2 minus 1 over 2x plus c is what I should get as the final answer. Alright, let me do just one last thing. Downloads, open. Why are you confused, TJ? What did we miss? You're wondering why I didn't do long division, is that right? Or so the reason, okay, which part of the working are we stuck at? I'll throw some line numbers and then you can tell me. So we've got 1, 2, 3, and 4. Right. Because integration of 1 is x, and then 1 over 2x just becomes ln of 2x over 2. Because see, normally you would use long division if you can't cancel the items out. Like if you look at question number 5, right? You've got x minus 5 in the denominator. So you would actually, if you separate all the elements, you would write it like this: 2x squared over x minus 5 minus 4x over x minus 5 plus 3 over x minus 5. Now, we can't really do anything here like that because, you know, you can integrate the 3 over x minus 5. Oh, the third one. Right. Okay, that's what you don't get. So remember, it's integral of 1 over 2x squared dx. We write this as integral of x to the power of minus 2 over 2 dx, which then equals, we would go x to the power of minus 2 over 2 we would add 1 to the power and multiply by the new power. So the new power is -1, and we're going to get x to the power of -1 over -2, which is the same thing as saying negative x minus 1 over 2, which is the same thing as saying -1 over 2x. I'm guilty in saying that from here to here, that's highlighted, that's basically this entire part there. That I've just done it in like almost like one shot. Sukni, did that make sense for you, mate? Like, all right, cool. Let me throw the link to you guys. Let's just make it. Just gonna do it now. All right, folks. That's pretty much us covered for today. What we're going to do now is, if you're still on the stream, I will send you the link to the giveaway stream. Oh, you're also rated as X. Sorry. Did that work? Try that link and see if that's going to work or not. Yes, it is going to work. So jump on there, and then we're going to do like a quick, in 10 minutes, we're going to do like 3 t-shirts. But apart from that, thank you so much for joining today. On Sunday, we'll go through, what do we call it? We're going to go through, what's that thing? Integration by substitution. That's the one. We're going to go through that. All right. So, the link works. Cool. I'll see you there, and we're going to do it real quickly. So if the people don't come, they don't come. That's their problem. Awesome carrots already there. All right. I'm going to stop this stream and just jump onto the other one. Thank you, folks. I'll see you Sunday if you're not there for the stream, for the t-shirt giveaway, I will see you Sunday. Bye. Where are we ending? Ending this stream.